In this video, I'm going to determine whether carbon dioxide or sulfur dioxide is polar or non-polar. And I'm going to look at the type of bond that exists between them. Now, for carbon dioxide, I will start by drawing the distribution of electrons within that molecule. So, I will have the two oxygens on both sides of carbon. Now, based on the electronic configuration of carbon, carbon is 2 to 4, which is 1s2, 2s2, 2p2. That's UFBO electronic configuration, to be precise. And oxygen is 2 to 6 with 1s2, 2s2, 2p4. Now you'll realize that oxygen needs 2 electrons to be stable. Carbon needs to donate 4 to be stable. So the 4 electrons that are supposed to be donated by carbon must be distributed between the molecule. Therefore, each oxygen will accept 2 electrons from carbon, and at the same time they also give 2 electrons to carbon, thereby leaving each oxygen molecule with 2 lone pairs of electrons that are distributed evenly as shown above. Now, after doing that, you will realize that the bonded electrons in CO2, now carbon as the middle atom has no lone pair of electrons. Therefore, carbon will have a double bond with both oxygens, and the oxygens that are bonded to the carbon will have lone pairs of electrons on them. Now, based on Pauline's electronegativity, you'll realize that oxygen has a 3.5 and carbon has a 2.5 Pauline's electronegativity, and the difference between them will give us a 1 Pauline's electronegativity. Now, for this matter, you will realize that being that it is above 0.5, CO2 has a polar covalent bond between them. Now, the carbon will bear a partial positive charge and oxygen will bear a partial negative charge, being more electronegative. So if we draw the dipole moments cancels because they are moving in opposite directions. Therefore, we say the dipole moments cancel out. For this reason, CO2 has a net dipole moment of 0. Therefore, it is a non-polar molecule. However much it is having a polar covalent bond, but the molecule is non-polar. For sulfur dioxide, we are going to talk about the distribution of electrons. Based on number, I'm having 1 sulfur and 2 oxygens. Now the total number of electrons to be distributed within the molecule are 18 electrons. So I'm going to put sulfur in the middle and oxygen on both sides. Now the first thing I'm going to do, I'm going to treat every bond as a pair. So the first bond will take a star and a dot, another bond will take a star and a dot, and I'll subtract the total number of electrons that are 4 from 18, I get 14. Then I'll introduce lone pair of electrons in both oxygens. When I do that, you'll realize that each oxygen will have 3 lone pair of electrons, so that's a total of 6. Then the remaining will be placed on sulfur. So based on that, you'll realize that both oxygens are stable, but sulfur in the middle is not stable because it is only having 6 electrons around it. So what should we do to make sulfur stable? That's the question now. what should we do to make sulfur stable? Now I want you to look at the hybridization. Whenever we are forming hybrid orbitals, and sulfur is doing that, you'll realize that one of its electrons will always be shifted to the d orbitals. Now an electron will shift from px to the d orbitals in the formation of hybrid orbitals. But for this matter, how do we make sulfur stable? Now, the principle of the lone pair of electrons found on oxygen now can come in. Each oxygen will donate a pair of lone pair of electrons, then will form double bonds between sulfur and oxygen on both sides. Now each oxygen will only remain with two pairs of lone pair of electrons. Now for that matter, sulfur will now be stable, and sorry I did not highlight that. Now CO2 molecule is linear. Now sulfur will now be stable, but now since it is now having excess of electrons around it, now the electrons will be repelling each other. The lone pair of electrons will be repelling the bonded pair of electrons, making sulfur to adopt a unique type of shape. Now the shape is bent, or sometimes you can call it V shape, but the most pronounced is bent shape. Now based on Pauline's electronegativity, sulfur is 2.5 and oxygen is 3.5. The difference between them is 1. Now if we draw the dipole moments will not cancel out. So we say sulfur dioxide has a net dipole moment. So when it is having a net dipole moment, so we say that sulfur dioxide is a polar molecule. It is a polar molecule because the dipole moments are not cancelling out. If you get the difference between the dipole moments, you'll realize that it is a 3.5 minus 2.5, which is giving you 1. Therefore, we can conclude that sulfur dioxide and carbon dioxide both have polar bonds because of the electronegativity of 1. They have polar bonds between them, even though CO2 is nonpolar and sulfur dioxide is polar molecule based on that analysis. Thank you very much.